Turning packaging waste into new products, a pipe dream?
Not at all. This is a challenge taken up not only by FostPlus, but also, and more importantly, by the 11 million people living in Belgium.
This challenge involves sorting out household waste for recycling into polar clothes, plastic bottles, flasks, bicycles, cans, bins, aerosols, boxes, glass bottles or jars, padding, tubing,
while reducing our carbon footprint quite considerably.
Taking up this challenge also means achieving the targets. Belgium has established an illegal framework based on the European Packaging Directive designed to recover 90% of packaging, including at least 80% through recycling.
But what happens to the packaging once it leaves the house? Why are the regulations the way they are?
Glass bottles, vials and jars represent the container glass fraction of packaging waste. Belgium's container glass collection system is mainly based on the use of bottle banks.
Glass bottles, vials, and jars have to be free of residue because organic matter creates a foam on the surface of molten glass, thus preventing the furnaces from operating properly.
Solely container packaging should be disposed of in glass banks, while porcelain, ceramics, terracotta, and especially heat-resistant glass, such as domestic oven dishes, are excluded.
This is important because their melting temperatures are not the same as those of glass. Hence, the solidity of recycled glass will be adversely affected if it contains unmelted parts.
Also excluded are bulbs and neon tubes comprising infusible components, as are opaline items, glassware and crystal glass, because they have a different composition.
Colored glass on one side and colorless glass on the other. This is of crucial importance for effective recycling, as only colorless glass is recycled into colorless glass, and colored glass is always recycled into colored glass. The collection vehicles are specially equipped to ensure this separation.
Once they reach the recycling plant, these two glass grades will undergo the same process, but separately. A magnetic separator removes any metal components.
Foreign bodies are removed by hand.
The glass is then crushed.
Next, suction equipment is used to remove lightweight materials such as corks and scraps of labels.
Optical sorting machines remove any other undesirable materials that might remain, such as ceramics, heat-resistant or lead-containing glass. This information is analyzed for the purpose of controlling a series of ejection nozzles further along the line that release compressed air to eject the undesirable items.
Finally, all that is left are scraps of glass called cullet. This cullet is melted in the furnaces, after which it reappears on the market in the form of new bottles and jars.
30 kilos of glass per inhabitant are recycled every year in Belgium.
Recycled glass reduces the carbon footprint and cuts down on the amount of raw materials used: soda, limestone, and sand.
Using recycled glass results in a 30% cut in energy consumption.
Not forgetting that glass can be recycled endlessly without losing any quality.
The collection of paper and cardboard applies to old paper, newspapers, journals and magazines, packaging boards and cardboard boxes.
People have to remove non-cellulose components, such as plastic films, in order to maximize the effectiveness of the recycling process.
Paper and cardboard are collected separately from other materials in order to guarantee the quality required for optimum recycling. They are sent directly to the recycling plant where they are processed in several stages.
The first operation is to remove any residual contamination in the flow in order to produce the mixed paper and cardboard grade.
A more rigorous sorting system may be deployed to separate the different grades. A sorting machine next separates the large cardboard boxes. Then the smaller items of paper and cardboard are sorted by hand and/or automatically to separate the different grades: mixed paper, cardboard, and paper for de-inking.
The different grades of paper and cardboard are next baled, that is, compressed, into large blocks to be sent to the paper mills.
These bales are then added to a pulper and mixed with water so the cellulose fibers are cleared of contaminants such as staples and residual products.
The production of certain types of paper requires the ink to be removed from the pulp via de-inking, after which the water is purified.
New cellulose fibers may be added to produce the grade required.
The resulting paper pulp is drained and dried before being packed in reels, to be used afterwards to make new paper and cardboard packaging.
Recycling paper and cardboard means making the best use of wood fibers. More or less 65 kilograms of paper and cardboard per inhabitant are recycled in Belgium every year.
PMD. These three letters show that the blue bag is intended solely for plastic bottles and flasks, metal packaging, and drink cartons.
The contents of PMD bags have to comply with the relevant requirements because this has an impact on how well items are sorted at the sorting center.
It is important for the sorting regulations to be observed. Otherwise, poorly sorted packaging can undermine the recycling process.
Household packaging has to be emptied before being deposited in the blue bags in order to avoid soiling the materials due to be recycled.
The volume of the packaging should not exceed 8 liters. Otherwise, it is too high to be conveyed on the sorting belt. Large packaging may also include agents added to ensure its solidity.
Packaging that contain toxic substances, unblocking products, corrosive descaling or engine oils may not be deposited in the blue bags, as they are dangerous for staff, machinery, and in certain applications for the recycled products.
In the sorting center, the contents of the blue bags or PMD bags are sorted into 7 matter fractions for recycling.
The first 4 are colorless transparent PET bottles, blue transparent PET bottles, green transparent PET bottles, HDPE bottles and flasks.
Other items of plastic packaging such as bags, trays and punnets, yogurt pots, cups or tubes comprise a wide range of plastic types and often combine different kinds of materials.
No process has yet been developed that can guarantee the effective recycling of these kinds of packaging. The recycling process is further complicated because of product residues contained in the packaging.
The last 3 are steel packaging, aluminium packaging, and lastly, drink cartons.
Each of these fractions is sorted according to highly stringent specifications to guarantee recyclers the high quality of fractions bought on the Belgian market, a key factor in guaranteeing a sustainable market for recycled materials.
Let us now consider the various sorting stages. The sequence may vary from one sorting center to another, but the basic principles are always the same. An opener tears the bags open to release the contents.
The packaging is then deposited in a rotating drum to remove any components that are too small.
A ballistic separator and a blowing apparatus are used to recover the empty blue bags, while a magnetic conveyor recovers the steel packaging.
The plastic bottles and flasks are then carried through a first group of infrared detectors identifying the items of packaging according to their material, PET in this example.
Several compressed air jets are used to project the detected bottles a bit further onto a specific moving carpet, positive sorting in this case.
The remaining flow falls into a space between the 2 moving carpets to continue on its way. It will then be sorted further on according to the same principle.
The second group of detectors also uses the infrared system to separate the PET according to its color.
The first fraction identified is the colorless transparent PET. Then it is the turn of the blue PET bottles to be selected. Finally, only the green PET packaging remains.
The following stage introduces an eddy current separator to recover the aluminium packaging.
The drink cartons are separated via optical sorting. A manual sorting procedure is applied in order to correct any sorting errors.
Most of the fractions are pressed into bales to be sent to the recyclers. All the bales are weighed and labeled to ensure they can be traced, which is most important in the event of quality issues.
The empty blue bags can also be recycled or converted into energy.
The residue content is currently 15%, thanks not only to the various information campaigns, but also to the checks made by those responsible for collecting the materials, who are required to affix a red hand sticker in the event of a failure to comply with the sorting instructions. PMD residues are used to produce energy. Some sorting centers can recover some of the residues for recycling.
Roughly 15 kilograms of PMD packaging are recycled per inhabitant every year in Belgium. Let's now take a look at the recycling stages for PET, generally used for transparent bottles containing water or fresh drinks. When they reach the recycler, the PET bales are opened and loaded onto the conveyor.
The first recycling process stage involves pre-washing. The bottles are placed in a drum where a hot water steam and rotation system is applied to remove surface impurities and labels.
Optical sensors are used to undertake a quality control so as to correct any sorting errors, while a metal detector is operated to remove any metal present by mistake, such as cans.
As soon as the automated control cycle is completed, the bottles undergo a final visual inspection.
The bottles are then placed in a first crusher, which in this case takes the form of a drum with blades, rotating quickly in hot water to reduce the bottles into 20mm flakes. The pieces of PET produced then undergo a 3-stage washing process.
During the first density separation stage, the material is deposited in a tank where a density separation process is applied to separate PET flakes on the one side
and HDPE and polypropylene flakes from bottle caps on the other.
The second stage involves intensive friction washing in hot water. The flakes are immersed in a water and detergent solution so that they rub together to eliminate any impurities.
The third and final stage is based on rinsing to eliminate any final residues there may be.
The washing phase is followed by the centrifuge, which is used to remove as much water as possible.
The flakes are then pushed into the dryer by a ventilating fan to follow a zigzagging course before emerging completely dry. An endless screw then pushes the bottle pieces into a second crusher to be turned into tiny 8mm flakes.
These flakes are drawn towards the final stage of the process, the dust removal stage, using a top suction system to eliminate any residual contamination.
Next, they are sent to the blending silos where the material is constantly in motion. The PET recycling process is completed in the in-company laboratory, where stringent quality controls are carried out every day on the materials leaving the plant.
Recycled PET can be used to make a whole range of new common items. For example, to make new bottles, the granules of recycled PET are placed in an extruder to be molded into preforms.
After this stage, the preforms are placed in a blowing unit to be heated with lamps to make the plastic soft and flexible.
They are then deposited one by one in molds, where they are inflated by an air jet to be transformed into balls adhering to the wall, providing them with their final shape. As soon as they emerge from the mold, the bottles are ready to be filled, corked, packed, and marketed.
Recycled PET is also commonly used to make fibers for the textile industry, for example. The recycled PET flakes are melted in an extruder to be drawn into a large, ring-shaped mold.
The ring's surface has thousands of tiny holes through which the hot liquid plastic constantly flows, solidifying on contact with the air to become an endless thread. The technical characteristics of the fibers are then improved, as a result of subjecting them to a series of washing and lubrication operations.
The resulting fibers are used for padding in sofas, quilts, and winter jackets, or to make polar accessories and clothing, bags, insulation panels, internal linings for cars, and many other applications.
PET can also be recycled into punnets or strapping.
HDPE is most commonly found in flasks for shampoos, shower gels, softeners, detergents, and bottles for milk and yogurt drinks.
When they reach the recycling plant, the HDPE bales are opened and loaded onto the conveyor. As in the case of PET, HDPE recycling is a multi-stage process.
Crushing is the first processing stage. When this is completed, the scraps are taken to a washing system and subsequently placed in a flotation tank, where residual impurities and foreign bodies are removed while the HDPE floats to the surface.
The HDPE is dried by spinning, then stored.
Next comes the extrusion stage. The HDPE is heated in an extruder until its melting point, and then pushed with an endless screw through a filter to remove any aluminium and remaining contamination, and then through a sieve to form long filaments cut into granules with a blade.
The HDPE granules go through a quality control process in the laboratory. Once the materials have been checked to ensure they comply with the relevant requirements, they are placed in large bags and stored.
They are now ready to be sent and be used by companies as secondary raw materials. These companies dry the HDPE to remove any moisture it may still contain, then heat it in an extruder until it is transformed into a liquid via an endless screw mechanism.
3 different processes are then applied to produce items ready for use. Injection molding to make storage bins or pallets, extrusion to make cable and piping sheaths, extrusion blowing processes to make watering cans or cans.
Comprising steel or aluminium, metal packaging covers items such as soda pop cans and food cans. They are collected in blue PMD bags.
Steel and aluminium are sorted separately at the sorting centers. These packaging items are crushed, cleaned, and compacted by their respective recyclers, so they are ready to be sent to furnaces operating at very high temperatures.
The molten steel is transformed into plates, wires, or beams.
Meanwhile, the aluminium is cast into ingots before being used for various applications.
Recycled steel and aluminium is found in everyday life in the form of food cans, beverage cans, mailing cases, aerosols, or lids for jars.
But also in the form of bicycles or cars.
As in the case of glass, steel and aluminium can be recycled endlessly without losing any quality.
Drink cartons are also collected in PMD bags for recycling.
They generally comprise 3 different materials, each of which has a specific function. Cardboard for rigidity, aluminium for shelf life, plastic for sealing.
When they reach the recycling plants, they are mixed with water in a pulper. A rotary screw in the pulper detaches and separates the cardboard, plastic, and aluminium.
The cellulose fibers next go through the normal paper and cardboard manufacturing process. The resulting paper pulp is drained and dried before being transformed into reels to be used to make new paper towels, toilet paper, paper bags, or cardboard boxes.
Some recyclers recover the plastic-aluminium combination as a source of energy.
Other processes can separate the aluminium on one side to be melted to make new products and the plastic on the other to be converted into energy or to be recycled. Over 90% of household packaging is now recovered and recycled in Belgium thanks to the country's recycling system, thus saving roughly 670,000 tons of CO2 every year.
This achievement would not have been possible without the effective cooperation of all those involved in the collecting, sorting, and recycling process: the business sector, the public authorities, and, of course, the active participation of all citizens.